Okay, guys, I asked you to do the extra practice, which was on page 183. I asked you to do 17 through 25 odd. Here are the answers. Number 17 is 7.9. Number 19 is 39.99. Number 21 is 14.82. Number 23 is $207.85. And number 25 is 5.38 inches. If I say it correctly, though, it's 7 9/10, 39.99 hundredths, 14 82 hundredths. This is still the same. $27.85, 5 38 hundredths of an inch. All right, let's get to this. Number 17. 4.9 plus 3.0. 4.9 plus 3.0. Line of the decimal points. Tenths and tenths, that works. 9 plus 0 is 9. 4 plus 3 is 7. Now, what I didn't do is I didn't read the directions. I just saw the plus sign and right away I added. It worked out this time, but I could have made a silly mistake. Depends what the directions would have asked for. All right, number 19. 15.63. 15 and 63 hundredths plus 24 and 36 hundredths. Okay. Line up the decimal points. And we're just adding, so no worries about regrouping. I have hundredths and hundredths, that works. 3 plus 6 is 9, 6 plus 3 is 9, 5 plus 4 is 9, 2 plus 1 is 3. Pretty straightforward, no problem so far. Number 21. I will read the directions this time. It says find each difference. All right. 82 minus 67.18. All right. I'm reminding myself this whole number is really a decimal number. It looks like this. Minus 67.18. You know, before I write everything the way I should, let me check something. I have one place value, two place values. So here I have hundredths, here I have tenths. I'm just going to go ahead and add the 0 here and now. Why wait till I write it at the end? Doesn't matter when you write it, just as long as you write it. 82.00 minus 67.18. Okay. Decimal points, I don't forget. 0 minus 8. Nope, I have to regroup. There's nothing to take away from here, nothing to use. I can use this. Take away 1. That 1 goes here. I mess with 1 here. 2 minus 1 is 1. 1 goes there. I'm still regrouping. 10 minus 8 is 2. 9 minus 1 is 8. 1 minus 7. Can't do it. Regroup. 11 minus 7 is 4. 7 minus 6 is 1. And there's your answer. Now, a couple things. When you're subtracting in situations like this, you have to be very neat. It's too easy to get lost with all the numbers that are up here like, I'm losing track. So write it big. Well, not too big, but big enough so that you can see clearly what you're doing, right? And again, when you're done with this problem, if you want to check if it's right, because I know some of you are really unsure about your subtraction, then just use the whole numbers and see what you get. So the answer is going to be about 15, approximately. And look at that. It's pretty close. All right, 23. Financial literacy. It's a word problem. The current balance of Tammy's checking account is $237.80. Find the new balance after Tammy writes a check for $29.95. Okay, now here's the deal. When you put money in a bank, it's called the balance. Whatever money you have in the bank is called your balance. So in this bank we have $237.80. Now, I realize a lot of people nowadays, even your parents, don't really write checks anymore. Everything's paid either with a debit card or a credit card, or later on when you learn about this, with your checking account number, you just give it directly to whoever you're paying and just take it from there. But every once in a while, you will write a piece of paper called the check, on a piece of paper called the check. You'll write an amount for what you're paying for, what you're buying, and you'll write the name of the person you're paying. So for example, I can write a check to Ralph's. I'll put, pay to the order of Ralph's. And I put down the amount I'm going to pay them, $20.60. And so that check, that paper check, is like cash. That money gets taken out of your balance. Okay? So it gets subtracted from your balance. Okay? If you're still not sure what a check is, please look it up. Google it. What is a check? But basically it's just a piece of paper saying you're going to pay such and such person for such and such amount. But anyways, you write a check for $29.95. $29.95. Now I'm checking hundreds. That works. Decimal points are lined up. I'm subtracting. All right, let's do this. I have to regroup. I can't take away 5 from 0. So that becomes 10. And that becomes 7. 10 minus 5 is 5. 7 take away 9. That doesn't work. I have to regroup. That becomes 6. 17 minus 9. Now go slowly here. There's no reason you have to go fast. I'm going place value by place value. Doing things very carefully, as neatly as I can. Now I should be doing it in pencil, but I have these pens that are really sharp. I like these pens, but that's just me. You do what you think you need to do, what works best for you. All right, 6 minus 9. Can't do it. I regroup again. 2. That becomes 16. 16 minus 9 is 7. 2 minus 2 is 0. And then 2 minus nothing is just 2. And I need to write the dollar symbol because we're talking about money. So I started out with $237.80. This is what I'm left with after I write a check. It happens. You write a check, your money goes down. All right, last one. The melting point of sodium is 97.8 degrees Celsius. The melting point of potassium is 63.65 degrees Celsius. How much higher is the melting point of sodium? Okay, now in the book it gives you a little diagram, a little picture of a thermometer with the temperatures. You see which one's higher, which one's lower. But I'm going to just do it here anyways. Just maybe not the same thing, but I want to show you that you don't need a visual to understand this, as long as you understand your numbers. All right, we're talking about sodium. And we're talking about, what's the other one? Potassium, excuse me. Now, even if you understand what melting point is, you do understand numbers. Basically, a melting point is a temperature in which something melts. So sodium, it's 97.8 degrees Celsius. Potassium is 63.65 degrees Celsius. Now, it says find the difference. How much higher is the melting point of sodium? When it says how much higher, it means you have to subtract. Now, it's saying that this is higher than this one. How much higher is sodium than potassium? Now, again, if you panic because you see the numbers, like, I see the decimal numbers. I don't know what's bigger anymore. This has 3 digits, but this has 4. So this has to be more. It has to be bigger. Blah, 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 blah. And I get it. If you didn't know any better, it would look like this is the bigger number because it has 4 digits. And this has 3. But again, I ask you, take away the decimal point part, and what do you have? You have 97, I have 63. You should be able to see that 97 is bigger than 63. Okay? 97.8 minus 63.65. Place value check. Tenths, hundredths. Won't work. I need to add a 0 and next to 0. And why? Why does that work? Again, 8 tenths, 65 hundredths. It doesn't work. I'm going to show you since I'm already into it. 8 tenths minus 65 hundredths. I need hundredths. I multiply this by 10, that by 10. 80 hundredths minus 65 hundredths. Hey, I can subtract that. It works out. Okay. 0 minus 5, it doesn't work. I'm going to regroup. 10 minus 5 is 5. 7 minus 6 is 1. 7 minus 3 is 4. 9 minus 6 is 3. And there is your answer. 34.15 degrees Celsius. That's the temperature difference. And that, my friends, is extra practice. I hope this helped.